Hi everyone. I am Ahmed. I am Ahmed Tajuddin, and I will present the last subtopic for chapter 6, that is theory kinetics of the gases. Hopefully, you understand all the above subtopic earlier in this topic. So, for the theory kinetics of the gases, firstly, we will take a look at the molecular model of gases. Molecular model number one. The molecules are very small, corresponding to the distance between molecules. Number two, molecules moving in constant random motion. So that means we have one molecule of gas here. So it's moving randomly. So for example, it's moving in this way. So in this molecule moving in this way, and this molecule in this way, they are moving randomly. Number three, the molecules collide with each other frequently. So uh, I want to say here that when the molecules meet to each other, they will collide. So there will be another molecule here, and then they will collide frequently with each other. And then order motion made the molecules superimpose during random motion. So uh, during random motion, the gases will collide to each other. That made them superimpose to each other. So, secondly, we will take a look at the theory kinetics of an ideal gas. Okay, this is also known as the characteristic of the gases. Okay, firstly, the molecules moving in random motion with a variety of speed. So, for example, firstly, we have so one molecule here, it moving with 1 meter per second, and another molecule, it moving with speed at 3 meter per second. Okay, we move to number two. Molecules are separated by great distances relative to their size. Number three, collision between molecule with another are perfectly elastic, so there are no energy loss. So means when they are collide, after that it will be elastic. So means energy loss is zero. Number four, there are no interaction between molecules and they will interact during collision. This means the molecules will only interact when they are collide. So when they are collide, they are interacting with each other. So let's move to the next part of this last subtopic. So we will learn about real gases. What is real gases? Real gases refers to characteristic or behavior of gas where pressure is too high. Okay, pressure is too high and the temperature is near to the boiling point. So boiling point of each substance is different. So under real gases, we can divide it into PV diagram and PT diagram. But what is PV diagram and PT diagram? So let's take a look at PV diagram. Okay, PV diagram, yeah, it stands for pressure, and V is volume. In other words, that means PV diagram is a graph of pressure versus volume. So let's move. Okay, this is the diagram P. Because the pressure versus volume, so means that P will be the y-axis and volume will be the x-axis. So for PV diagram, you only to remember that low temperature make the gas farther from the ideal. So means uh okay, let's move to the next. Let's move to the next diagram. That is PT diagram. What is PT? PT stands for pressure over temperature. Okay, temperature. So that means pressure will be the pressure will be the y-axis and temperature will be the x-axis. So for this PT diagram, okay, it is also known as phase diagram. So PT diagram and phase diagram, it is the same. Okay, PT diagram shows all state of matter such as solid, liquid, gas. So okay, it shows that liquid, solid, liquid, and vapor. Vapor required to gas. So not okay. Melting or freezing process occur when solid, liquid changing at curve SL. So we look at local SL. So the solid changing from liquid, and liquid will be changing to solid. Whether the ice is making a ice or melting a ice will happen here at curve SL. And number two, boiling or condensing process at curve LV involving liquid vapor. Liquid vapor, and this is the curve of LV. And the last part of solid vapor transformation is called sublimation. It is occur at curve SV. Okay, sublimation is a new term for us. Okay, so sublimation is the process whereby at low temperature, solid will change to vapor without passing the liquid phase. So means solid directly change to vapor without changing without passing liquid. So okay, that's sublimation. Okay, number three, all points where the curves intersect is called triple point. So let's move to the diagram. Okay, so first we have solid. Okay, the curve here we have. Okay, I will extend the line here. Okay, and then from liquid they have a curve here, and LV the curve here. Sorry. Okay, and these three will intersect at this point. So these points are called triple point. So that for PT and PV diagram. Okay, under this chapter 2, there are two formula that we need to remember and memorize. So first is translational kinetic energy. We denote it as K. So translational kinetic energy formula is K equals to 1.5 kT. Okay, it is also same to 3 over 2 kT. Okay, noted that temperature must be in Kelvin and K is Boltzmann constant. That the value is 1.38 times 10 to the power of negative 23. Um, let's move to the next formula. We have root mean square. Root mean square RMS for the short form writing. Speed V. We denote it as V. So this is the uh, this is the formula square root of 3 kT over m. So just like I said just now, k is the Boltzmann constant, that is 1.38 times with 10 with the to the power of negative 23, and m here stands for mass. Noted that too that temperature T must be in Kelvin. I think that's all for this chapter. Thank you.